Hi guys, this is Rangabashim here. I'm currently pursuing a PG program in data science engineering in Great Learnings. I'm here to explain the Pearson's correlation. Pearson's correlation is most significant concept in statistical study. This is the relationship between two continuous variables, and this is the best method. It is a statistical test that measures the relationship or association between two continuous variables. It gives information about correlation as well as the direction of relationship. Yeah, we have two directions here. One is positive and negative. Positive is towards right and negative is towards left. This is what I said as the correlation as well as the direction of relationship. So positive it's towards right and negative is towards left. This x and y are the variables we are going to plot. This plot is known as the scatter plot, which shows how the data is correlated. So it will be easily visualized and the thing could be easily processed. There are certain assumptions that here independent of case, the case should be independent to each other. That is, we have two variables which are all independent and dependent variable. In our case, we should have both as independent variable. First, we see what is dependent and independent variable. We have water and plant. The plant grows how we feed the water. So on the basis of water, the plant grows. This is the relationship between two variables, water and plant. Okay. Independent means it should not be dependent. So we will be finding the independent variables correlation. Linear relationship. Two variables should be linearly related to each other. This case, we can see the scatter plot. At beginning, we saw that they were linear, just like a line. This homoscedasticity. This is the really great concept. I will be making a separate video for it in future. Now we will just roughly go through the concept. The residual scatter plot should be roughly rectangular in shape. That is, we have a sample experiment in our hand. So let's say we build a model. Our expected answer is 10. For example, I am saying our expected answer is 10. But our model is predicting up to somewhat 80. So here is the thing. The predicted value and the observed value. We predict that the answer should be 10, but the observed value is somewhat 8 or 8.5. The difference between the two, if we are expecting, that is we are predicting up to 10, we observed as 8, the difference is 8. So the variance in this is known as always the constant for the random variables is considered here. This is a small intro of homoscedasticity. I'll be later making a video in detail about this. So we have got a view on homoscedasticity. These have some properties. The coefficient of the range. See, we have positive and negative in graph. We have four quadrants. So in that we have from the range begins from +1 and ends in -1. In linear regression and all, we will be having, we don't have starting point and we don't have end point. It is up to infinity. In case of logistic regression, if we take, we have from 0 to 1. So in that case, here we have +1 to -1, where +1, which is of positive, it it is towards right, and the minus indicates it is towards the left, and 0 indicates there is no relationships there. Okay, the plot will be somewhat scattered. It will be not in a linear take. First we saw that linear now. So here there will be no linear thing, and it will be scattered here and there. So pure number. Pure number is just that the inches and quintals. Inches is of size and quintal is of weight. So even though it is not equal or it is not converted, the value doesn't changes here. The symmetric correlation of coefficient between two variables is symmetric. This means the x or y or x, the coefficient of the value remains the same. If we plot weight to age or age to weight, that is x and y or y or x, the output we will be getting the same. This is the degree of correlation. First we saw that positive and negative. Here we have some extra things. The perfect is that if the value is near plus or minus 1, then it is said to be perfect correlation. As one variable increases and tends to, okay, if it is positive or negative, so we have a perfect correlation here. And then the second is high degree. Here in the first slide we saw it is of 0.50 and minus 0.50. So in that case it is strong correlation, and moderate is of 0.30 to 0.49 plus or minus, it will be medium correlation. Yeah, low degree is of below, it is the smaller relationship. Zero correlation, as said first, there will be no correlation between the variables. So here we saw that we have correlations high, low and medium. This is if there is a strong positive correlations, they both will be contributing something to your model. If the degree is low, they will be less contributing. If there is no correlation, then we should not consider those variables into our models. Yeah, there is an interesting thing today I have noticed, that I was just going through my mini project file. So I have found this question, the Pearson coefficient of skewness. Here, for example, we have given the BMI. So I have not converted into the data frame. Just we are moving as it's a list. So we have to find the Pearson coefficient. So this gave me the idea of making this video. Thanks for watching this video. I think so. The concept is somewhat easy and you could have understood to a basic thing.